We are good to go. Okay, let me switch it over now to well, guys, do you have any questions about anything? Anything in particular before we just start rocking and rolling? What's up,
I do,
Chassie?
if it's okay.
What's up?
49 through 57, the odds on page 255. I was wondering if you could do an example of those. For some reason, I struggled with them.
Yeah, no problem. That's no big deal. Yeah, now these are all going to be either vertical or horizontal lines. So these are really good examples. So let me switch over.
I think I just maybe didn't understand the instructions for some reason. It's worded, I don't remember it being worded that way.
Okay, yeah, no problem. I don't mind going over it.
Okay.
Let me click over here. Boom. Okay, so I'm going to choose some even ones. That way, if you want to go back and do the odds, because it's the same thing, right?
Okay.
So yeah, let's do 50 because it's just like 49. So 50 states y equals 4. Okay, notice I think we did one like this in class, but notice that there's no x value. So I'm going to kind of go on a little talk about vertical and horizontal lines. If there's no x value and we just have y, yeah, this is just a horizontal line, right?
Well, yeah, okay, I actually get that. I think I just understand the instructions then.
Okay, give me a different one then.
Well, I guess I didn't realize that we're just plotting either horizontal or vertical lines on it. I just didn't understand the instructions.
Oh, okay. Okay, so you got to figure it out?
I think so. We're just going to plot the 4 and make it a horizontal line, right?
You are exactly right. Like this would look like this.
Okay, well then that was a dumb moment for me then. Sorry.
No, it's okay. It's okay.
For some reason I struggle with 71 to get the right answer.
Okay.
It's probably a dumb moment too, but
no, that's okay, because I did want to go over one of these where we actually have to find the intercept. So 71 is a great question. So 71 gives us an equation with an x and a y. So therefore we know we have some sort of slant going on. And it asks for the intercepts, right? So I haven't gone over how to find the intercepts in a lecture, but it's pretty straightforward, and it's not a big deal. So if I want to find the x-intercept, which we're going to do more often in this class, we have to set y equal to 0. Okay. So you set y equal to 0, and really what you're trying to find is the x value for y equals 0. So in this equation, if I set y equal to 0, I get 8x minus 2 times 0 plus 12 equals 0, right? So you wind up with 8x plus 12 equals 0, and then just solve, subtract the 12, divide the 8.
I remember that from the last semester now.
Yeah. Oh, no, it's okay. And I'll go over it. It's not a big deal. And so then now 12 eighths would both divide by 4, right? So that's 4/3. No. 12 divided by 4. I got that.
3 halves.
3 halves, right? Yeah, negative 3 halves. So the x-intercept is going to be negative 3 halves 0, right? Because y equals 0, and then we found our x value when y equals 0. This is going to turn into a bigger, here, let me spotlight my video so you guys can see it. Hold on. This is going to turn into a bigger thing, bigger issue, I should say, later on, once we have higher order equations, right? This is just a first order equation because the x values just raised to the first power. Now let's find the y-intercept. Now I'm going to be lazy and just go dig another piece of paper out. Not lazy. I'm just going to kill some trees. Now we know one coordinate is negative 3 halves 0. And the equation is 8x minus 2y plus 12 equals 0. So if I want to find the y-intercept, I just set x equal to 0. Now, right, it's always the opposite. So you set x equal to 0, and you'd get 8 times 0 minus 2y plus 12 equals 0. This goes away. Negative 2y plus 12 equals 0. And then just follow it out, right? Subtract 12. Divide negative 2, and you wind up with y equals 6, right? So the other coordinate then, or the other intercept, would be now our x is 0, right? And our y value when x equals 0 is 6. So if I want to graph it, just because I'm curious.
I was making it harder than it had to be.
That happens. It's not a big deal. 1, 2, 3, 4, 5, 6. I know that's my y-intercept. -3/2 is right there. So that's my x-intercept. So it's just another way to graph it. Because they're straight lines, we can do this, right? If this wasn't a straight line, which we're going to get to the further along we go in this class, if this wasn't a straight line, we couldn't graph it with just 2 points, right? We need many, many, many points to kind of see the shape. But because we're dealing with straight lines, just graphing the 2 intercepts is an easy kind of way to do it, actually, for graphing by points.
Okay, thank you.
Yeah, no problem. Those are great questions. Any other questions from the homework before we get rocking and rolling? Man, my back's killing me. Okay, let's see, 2.4. Oh yeah, today's 2.4, which is one of my favorite titled sections, just like more on functions. 2.4 is titled more on slope. And there's really 2 topics in 2.4 that we're going to go over. First is parallel and perpendicular lines. So we got parallel and perpendicular. Those are shortcut ways to say parallel and perpendicular. I just don't want to write them all out. Okay. That means parallel, just 2 dashed lines that are parallel to each other. Perpendicular lines, it's like an upside down T because they're meeting at a perpendicular angle. So we got parallel and perpendicular, and then average rate of change. Okay, average rate of change. So there's really just 2 topics. And parallel and perpendicular are really just kind of an addition to, or I should say more on slope, which isn't a big deal. Average rate change is its own kind of thing. So I'm going to kind of teach this just how the book goes over it. It's kind of boring in my opinion, but it's just how it is. It incorporates knowing how to find the equation of lines, which we just learned from 2.3, right? If you did 2.3 homework, you know how to find an equation of a line. If you didn't, this part's going to look kind of hard because you need to go back and do 2.3 homework, okay? And I'm going to teach it just like with the example because it's pretty straightforward. Like this is example 1. Write an equation of a line passing through -3, 1 and parallel to the line whose equation is y equals 2x plus 1. So we go through -3, 1, and then we're parallel to y equals 2x plus 1, okay? So the rule here that we have to know is if 2 lines are parallel, that means they've got the same slant, right? I mean, if I kind of drew 2 lines that were parallel on this graph, they'd have the same slant. So what that means is these 2 lines have the exact same slope, okay? So parallel means same slope. So remember, if I want to find y equals mx plus b, which this is what this is asking for, I'll put that underneath it. Find y equals mx plus b. If I want to find y equals mx plus b and I'm given a point and a slope, I've got to start in point slope form. So -3, 1, and I know my slope is 2 because it's parallel to that line. So I'm going to first put it in point slope form. Now it's a minus a -3, so that's x plus 3, right? If you did the homework, that shouldn't be a big deal. And then you just solve for y, or yeah, solve for y. So we get y minus 1 equals 2x plus 6. And I'm going to add 1, and I get y equals 2x plus 7, okay? So now notice, just to kind of check this, these 2 lines are parallel, right? They've got the same exact slope, but different y-intercepts. So if I graph them, they're going to be parallel to each other, okay? So I know that this part is satisfied. If I want to check to see if it goes through this coordinate, which I didn't talk about in the last lecture, but if you want to check to see if it goes through this coordinate, you can plug in the x value to see if you get back the y value. Like if I plug in -3 here, this is just checking. -3, 1 goes through y equals 2x plus 7. Okay, this is me checking that. Remember, this is an x and this is a y. So I get y equals 2 times -3 plus 7, -6 plus 7, 1. Yeah. So when x equals -3 for this equation, y turns out to be 1. So I know it works out. So look, I found a line. This line goes through -3, 1. Checked it there. And I know it's parallel to this equation because the slopes are the exact same. So I'm good there, okay? And if you did the homework from last time, you'll know this looks really similar, right? This looks very, very similar to that last homework. That like the bulk of the homework there in the middle. Okay. So let's do one that's perpendicular. It's a little different because perpendicular lines aren't the same. They're considered opposite reciprocals. So if I've got, I'm going to make one up. So we go through, let's say 1, -2, and we're perpendicular to y equals, I don't know, -3/2 x plus 4, okay? And I'm making this up completely. So we go through 1, -2, and we're perpendicular to y equals -3/2 x plus 4. So the slope of this line is -3/2, right? Now, perpendicular lines are not parallel, so it's not the same. A perpendicular slope, you're going to take this fraction, flip it, and change the sign, okay? It's called opposite reciprocal, okay? You flip it, change the sign from a negative to a positive. If it was positive, you make it negative, okay? So then my slope is going to be a positive 2/3 because I flipped it and I changed the sign.
So to get perpendicular, flip it.
Okay, so now let's think what we actually have. The slope we're going for is 2/3. I know we go through 1, -2. I'm going to do this whole process over again, okay? I've got a point, I've got a slope, I'm going to start in point slope form. So it's going to be y plus 2 equals 2/3 times x minus 1, right? Minus a -2, and then there's my slope, x minus 1. And then I've got to get into y equals mx plus b. That's what we're going to do in this section. So distribute the 2/3. I get y plus 2 equals 2/3 x minus 2/3. And then I've got to subtract the 2. So I got to add fractions together. You should know how to add fractions together, really subtract them together at this point. But -2/3 minus 2, that's the same as saying -2/3 minus, well, 2 written with the denominator of 3 would be 6/3. So that winds up being -8/3. So y equals 2/3 x minus 8/3, okay? If you don't know how to do subtraction, with fractions, it's in that TI calculator, and just Google how to subtract fractions in TI calculator, and it'll pop out and tell you exactly how to do it. So you don't have to, I'm not going over it. I don't want to do it. Okay, your calculator will pop that fraction out. But look, this equation, so let's look at both of these, okay? This is what we started with. This equation is definitely perpendicular to the other equation, right? My slope here is -2/3 or 3/2. I flip it and change the sign, I get a positive 2/3. So I know it's perpendicular. If I wanted to check to see if it goes through it, now I'm going to do this in my head. X equals 1. If I plug 1 in here, this would be 2/3 minus 8/3, which is -6/3, which is -2. Okay, it pops out the y value. Okay, so I know that this equation satisfies these two parts of the question. Okay. This equation satisfies both parts of that equation, or this equation satisfies both parts of the question, I should say. Any questions? Okay, I'm going to give you a few of these to work, and you'll notice they're a lot like the homework yesterday. But some of them you might have to try to find the slope. Some of them it's not given completely. I'm going to steal it straight from the book. I'm going to just steal some even ones from the book. This is number 8. States, now look, the question says, use the given conditions to write an equation for each line in point slope and slope intercept. And we go through -4, 2, and we're perpendicular to the line whose equation is y equals 1/3 x plus 7. Okay, so I want you to try that one. And then Ugh, I don't like number 10. Horrible one. We'll do number 10, but we're going to do it a little different. Actually, we're going to do 12, but we're going to do it. We need a parallel window now. Let's do number 10 as well. So 10 states it goes through -1, 3, and it's parallel to 3x minus 2y minus 5 equals 0. Now, number 10 asks us to put it in general form, but I'm going to stick with slope intercept form. I'll show you what I'm talking about here. But look, you're going to have to solve for y in this equation. Oh, no, it's perpendicular, guys. I'm sorry. No, it's parallel. This is number 10. Yeah, parallel. You're going to have to dig the slope out by solving for y for this equation, okay? Try those two. I'll give you just a minute. And it's okay if you don't get done, but just to kind of see where you're at. Okay, I'm going to start on, if you're still working, that's fine. I'm just going to start, see how far I can get. So in this one, I'm perpendicular to this. So I know the slope I'm looking for, it's not going to be 1/3. It's not the same. I'm going to flip it and have to change the sign. So it's going to be -3, right? -3/1, it's just -3. So my point is -4, and my slope is -3. So y minus 2 equals -3 times x plus 4. Now I've got to solve for y, so distribute the -3. Y minus 2 equals -3x minus 12, right? Add the 2. And I wind up with y equals -3x minus 10. And again, so these two equations are definitely perpendicular. 1/3, -3 are opposite reciprocal equations. If I plug -4 in here, I'd get -4 times -3, that's a positive 12, minus 10, I get back positive 2. So I know that this is the equation I'm going for, okay? Any questions about that? I mean, if you got it wrong, that's fine. I mean, it's just practice. I just want you to kind of see where you're getting it wrong so we don't make that mistake later on. Okay, the second one though, we're parallel. So that means I got to dig this slope out, right? So I'm going to solve for y here. I'm going to subtract I'm really going to move the 3x and the -5 to the other side in one step, okay? So I get -2y equals, that's going to be a -3x on the other side and a positive 5, right? Then I divide by -2. And I wind up with y equals 3/2 x minus 5/2, right? So now this equation, now we're looking for parallel, so it's got to be the same slope, right? So my slope is going to be positive 3/2. So there's my slope, there's my equation. I can kind of go to work on that, okay? Oh. Any questions, guys? Okay, cool. So let's just keep doing what we've been doing. So y minus 3 equals 3/2 x plus 1, right? Distribute the 3/2, we get y minus 3 equals 3/2 x plus 3/2, and then add 3. Now 3 plus 3/2, now 3 is really 6/2, right? So this winds up being 6/2 plus 3/2, so that's 9/2. Boom, okay? So a quick check, look, once we solve this, we can see that these two equations are parallel, right? They've got the same exact slope. If I plug -1 in here to that x, that becomes -3/2 plus 9/2, so that's a positive 6/2. 6/2 is just 3, right? Pops 3 back, so that checks out, okay? The coordinate checks out, and so does the line, the fact that they're parallel and not perpendicular, okay? Guys, any questions? Am I just that great at what I do? No, I'm not. Okay. Comments, guys?
I'm bad with fractions. That's my comment.
No, I'm telling you, if you Google or YouTube how to add/subtract fractions on TI-80, if you bought the 83 or 84, it doesn't matter. It'll pop up, and you don't have to worry about fractions ever again, Nathan. Okay?
Really?
Okay.
Yes, really.
I hate fractions too.
We all hate fractions, okay? And
I'm still looking at it, trying to figure out how the heck I did come up with y equals 3x minus 5/2. Never mind, I did come up with that.
that's good.
I'm trying to come up with this other crap.
Is the TI-83 the newest one?
No, 84 is the newest one. I'm not, and so you can find an 83 cheaper. There's an app on your phone called, or if you have a smartphone, of course, called Calc 84, and you could use that. I mean, you won't be able to use it if we have a proctored final, but that's a free TI-84 really on your phone.
Well, I'm gonna buy one. Not an 84, but an 83 probably.
Yeah, I would get an 83. It's the same stuff. 84's just got fancier colors. That's the only difference.
So on
Yeah.
number 10, we didn't have to go on to write it any further, did we? I think
Oh,
that's what I
I'm sorry, Chastity. I couldn't tell what you were saying.
on number 10, I'm just trying to figure out what I did here because I have the answer that you have,
Yeah.
but I must have tried to go further and write it. And
Did you try to add it together because it had a common denominator?
No, I came up with that answer, but I tried to go further with it somehow. I'm trying to figure out how I did. I'll figure it out later. But
Okay. Yeah. No, I mean, like once you get it into, this is our mx plus b. It looks weirder because it's fractions, right?
Yeah.
But this is our mx plus b. I mean, our m is 3/2 and our b is 9/2. I mean, if I wanted, you could graph it too if you wanted to. That's not a big deal. It just would be on fractional. Instead of like the nice units, it's on fractional units.
Okay.
Okay. Yeah, that Calc 84, I use it a lot because it's, you know, it's already in my pocket instead of having to.
I'm gonna be doing the calculator thing because I bought one of those.
It really, and I told you guys to buy it at the beginning of the year. We're going to use it a lot more for other stuff coming up.
Yeah, I have one. I don't even know, but I just don't even know how to use it. So.
Yeah. I'll go over like you've never used it, but I'm telling you, if you just Googled how to put in fractions, how to pop out fractions in there, it's a very basic function on that calculator.
Okay, cool.
Yeah. Okay, the next is average rate of change. So let's go over that. Average rate of change. Okay. So the average rate of change really is just the slope, but with not straight lines. I know that sounds goofy, but it's slope for unstraight lines. So let me give you an example, like without the equation, because it's really just the slope equation. But if we looked at a graph, let's say we've got some funky graph. It looks like this. Now, all I know is that this graph goes from, let's make it go from -1, 2 to 3, 1. Why not? But we're going to make it do a lot of weird stuff in between. That's got to be a function. So maybe we can do that. It can go up here. It can go this way. It doesn't matter. But I know it goes through these two coordinates. Okay. So this is very apparently not a straight line, right? We have a curved line that's doing weird stuff, which is fine. But if I want to find the average rate of change, it really is just called it's the slope of the secant line. So let's talk about what a secant line is. A secant line goes through at least 2 coordinates on a graph. I should say it's a straight line. It's a straight line that goes through at least 2 coordinates on our graph, okay? So the average rate of change, which I'm going to write as ARC, is just the slope of a secant line. Just the slope of a secant line. So for this one, I'm going to graph the secant line with like a dashed red line to make it go through those 2 coordinates, okay? So this is considered a secant line because it's going through at least 2 coordinates, right? And these are the 2 coordinates that are on our graph, okay? And let's write those out. So this one is 3, 1. And that guy is -1, 2, okay? So the average rate of change is just the slope of that secant line. That's all it is, okay? So if I wanted to find the slope of the secant line, I can do it our easy way we talked about last time, right? We go down 1. So we rise 1, -1, I should say. And then we run 1, 2, 3, 4. So the average rate of change from, now here's the kicker here. You have to include the X values where this comes from. Because if I chose different coordinates on this line, it's going to have a different average rate of change. So I'm going to say the average rate of change from X equals -1 to X equals +3 is, and it was down 1/4, so -1, 4, okay? Average rate of change from X equals -1 to X equals 3 is -1/4. Okay? So now I'm going to do something a little different here. I'm going to say, well, what if we wanted to find the average rate of change from X equals -2 to x equals positive 1. Average rate of change from x equals -2 to x equals positive 1. Now, first off, I'm going to identify where those are on the graph. We're right here, right? That's x equals -2. And then x equals positive 1 is right here. Right? Do you guys see that? Now, this isn't going to be perfect, but I'm going to try to get this as good as I can. Okay? I'm going to use a blue line here. There's my secant line that goes through those two coordinates. Okay? And I just need to find the slope here. So now if I start here, and I want to wind up here, I need to go up 1, 2, 3, 4 units up, and then 1, 2, 3 units to the right, okay? So the average rate of change from -2 to +1 is going to be 4/3, okay? That's the slope of this secant line, okay? And there's an infinite number of secant lines on non-straight lines, okay? They're all over the place. Now I've got to kind of show you where these are coming from before I can just pop out the equation, because the equation doesn't really make much sense if you don't really know where it's coming from. So let me give you an example where I'm going to give you the graph, and then I'm going to equationally show you what's going on. This is the graph of the function f of x equals x squared, okay? So I'm going to graph this function out as best as I can, okay? We're only going to go to 3, +3 and -3, okay? So that means I got to go up 3 squared to 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we'll go up a little bit. So x, and then really this is f of x, right? Because it's y. So if I wanted to graph this out, if I put in -3, I guess I'll just put in coordinates and kind of show you where they're coming from. If I put in -3, I'd get -3 squared. So I'd get back a +9. Okay, let me try to do this. This is really not drawn symmetrically, but that's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9. +3 is right there. Okay, there's 3 negative, or -3, +9. So if I put in -2, I get back -2 squared. I get back a +4. 1, 2, 3, 4. Right there, right? If I put in -1, -1 squared is a +1. Right there. If I put in 0, 0 squared is just 0. Right there. And then this should be even symmetry, right? Because all we're doing is squaring it. So it should be symmetric around this y-axis. Let's show that. +1 squared is a +1, right? +2 squared is a +4. Yeah, these are symmetry, right? I'm putting in opposite signs and I'm getting back the same exact y values. So right there. And then +3, 3 squared is just 9. So right about there. Okay. So if I wanted to graph this, I guess I can just graph it like this. I get something like that. Okay, something like that. And we know what 1, 2, 3, 4, 5. We know 7 coordinates on our graph. Okay. So if I asked you, what is the average rate of change for f of x from x equals -1, they use the word 2, okay? 2x equals, we'll say to x equals 2. So from x equals -1, from x equals -1 to x equals +2. Well, I'm going to draw the secant line here, okay? X equals -1 is right there, right? So my secant line goes from here to x equals 2. Well, x equals 2 is right there. So it goes through these coordinates, right? So I need the slope of that line. Well, I know 2 coordinates on the line. I can do my whole rise and run thing. If I start here and want to wind up here, I need to go up 1, 2, 3. And then I need to go over 1, 2, 3. Hey, my average rate of change would be 3/3. So it's just 1. Okay. My average rate of change would be 3/3, up 3/3. And it would be just 1. Okay. Questions about that?
Just a
I'll show you
second.
the equation way to do it, and it's just based on the slope formula. Okay. The equation, which is in your book, actually, I'll write it down just like your book does, so it's not any different. The equation for average rate of change, it's on the bottom of page 263, and it looks like this. F of x2 minus f of x1 over x2 minus x1. That's the equation for average rate of change. Now remember, we know for this example, we know f of x is x squared, right? And you've got to know the 2x values you're coming from. You have to be given those. So I'm going to plug these into this equation. Now you can, it doesn't matter which one you call x1 or y1. I'm going to call this first one x2, I'm sorry, x1, and the second one x2. So if I wanted to pop these in the equation, it would look like this: f of 2 minus f of -1 all over 2 minus -1, right? My x2 is +2. My x1 is -1. So f of 2 minus f of -1 over x2 is 2 minus a -1. Now, what's nice is I did this whole chart up here, so I can tell you what f of 2 is. F of 2 is just 2 squared. It's 4. Minus, I can tell you what f of -1 is. It's just 1, right? It's right here. F of -1 is just 1. Divided by 2 plus 1, right? So we wind up with 3/3. We wind up with 1. Kind of neat. This is just the slope formula. Change in y over change in x, right? Just the change in y over the change in x. But instead of it being from a straight line now, we are coming from a line that isn't straight. It's all over the place. And we're cutting it with a secant line, okay? We're cutting it with a secant line. Okay? So let's look at another, actually, I'm going to keep that same equation, f of x equals x squared. And then I'm going to go from 2 different coordinates. I'm going to say, what is the average rate of change from x1 equals -3 and x2 being, let's do, we already did positive, did we do positive 2? Yeah, let's do x1 equals 1. So I want you to try this one real fast. So given the equation f of x equals x, actually I can kind of probably put it here. You might be able to see all of it, almost all of it. There we go. Actually, I moved my camera there. Boom. Okay, so what's, if f of x equals x squared, which we have up here already, right? What is the average rate of change from x1 equals -1 and x2 equals 1? I'm going to be right back, guys. I've got to run and get a drink of water. My throat's killing me. What's up, Jesse?
I was trying to keep up with you, but this little formula that you just gave us is just a formula way to find the ARC without having to find the secant line. Am I
You're
correct?
exactly right. In the end,
Okay.
you're just finding the slope of the secant line. Notice this is just slope, right?
Mhm.
It's y2 minus y1 over x2 minus x1. So
But
yeah,
you just go up and plug in. Okay.
and we'll do one here in a minute where it'll be kind of harder to do that. But yeah, that's all you have to do. That really is all you have to do. I'm going to do it formulaically, just because later on we're going to see some stuff with the formula. So let's do that. So if I plug in -3, so I'll call this x1. Okay, good. So f of x1, actually, f of -3 is going to be 9, right? And f of +1 is going to be 1 because you just square it. So if I go back to the formula for f of x2 minus f of x1 over x2 minus x1, f of x2, we found right here. Oh, actually, no, we found right here, right? This would be f of x2. So that's 1 minus f of x1, which turns out to be 9, over 1 minus a -3, right? So 1, 1, 1 minus a -3. And so we get -8 over +4, 1 plus 3. So we get -2. Is that what you got doing it on the, yeah, rise over runway, right? Same thing, -2. Great. So let's look at one now where it would be kind of weirder to graph per se, but we're going to use an equation for it to find the average rate of change, okay? It might not be too hard to graph, but I'm stealing this from the book. This is number 18. It's on page 267, number 18. We've got f of x equals the square root of x, and we go from x1 equals 9 and x2 equals 16. And they ask us to find the rate of change, right? Average rate of change, I should say, between those two coordinates. So let's do that. So if I'm going to do that, I need to find f of 16, which would be the square root of 16. We know that's just 4. We need to find f of 9. That's just the square root of 9. So that's 3. So if we go back to this equation, our f of 2, so f of 16, that's going to go first. That's going to be 4, minus our f of 1, which was f of 9. That's going to be 3. And then I'm going to do x2, so that's 16 minus 9, right, in the denominator, x2 minus x1. So I wind up with 4 minus 3, which is 1, 16 minus 9, which is 7. So 1/7, okay? That's my average rate of change. Now, you're more than welcome to graph this. If you graphed it, what you're going to see, oh, that's a big x value, though. What you're going to see is that at 4, 1, 2, 3, 4, we're at, no. At 9, we're at 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. At 9, we're at 3. And then at 16, 9, 10, 11, 12, 13, 14, 15, 16, we're at 4. And the graph looks something like that. It's just kind of harder to do the slope there. But you do go up 1, right? I mean, we know if we go from a y value of 3 to a y value of 4, we're going up 1. And if we go from a y value or x value of 9 to an x value of 17, we're going over 17 or over 7, right? A 9 to 16, I should say. We're going over an x value of 7. Okay. Okay. Let's look at like a real world example now. So if we chose one from the book, or maybe I can make one up. Maybe I can make one up. Yeah, let's make one up. Give me just a second. I'll make one of these up on the fly. Average. Okay, I have found a website that's it goes over, and look, this could all be fake news. I don't know. I'm going to steal it because it's a good example in the real world. But it's talking about the history of changes in the Earth's temperature. So it's going to give us an average temperature for an entire decade, okay? And I'm going to see if we can kind of see if, now this is in Celsius. I'm going to see if we can get an average rate of change here, okay? Let's see. So in 1880, we'll start there, okay? In 1880, we were at 13.73 degrees. So if we, okay, we're going to go by, we're going to start at 13. Actually, so I'm going to do a little break here, which means we're not starting at 0. And I'm going to start at 12. And then here's 13. And here's 14. So this is degrees Celsius, okay? And I'm not starting at 0. So these are going to look a lot more drastic in change than they actually are. But this is just me choosing a few decades to see if we can get an average change, okay? So in 1880, the average was 13.73. So, I mean, there's 0.5. Kind of bigger for each one of these. I'll do a little digit for the 0.75s, 0.25s. So in 1880, it is 13.73, right? And then, and this is a horrible example. This is what happens when you make one up. Yeah, no, let's scrap this example. It's pretty bad. The numbers are just too close. Hold on. Average. I'll just totally make one up. Okay. Let's look at the average gas price per year. Okay, and I'm going to make it up. Okay, average gas price per year, and we're going to look at like a 4-year snapshot. We're going to say, or 5-year snapshot. We'll say 2010, 2011, 2012, 1, 2, 3, 2013, and 2014. So this is a year in the 2000s. Okay, so 2010, 2011, 2012, 2013. And let's say in 2010, the average gas price was exactly $3. Okay, so 2010, the average gas price was exactly $3. And then in 2011, it goes down a little bit. The average gas price is, let's say, $2.50. Okay, so about right there. And then I know this is not true at all. I'm making these up to just kind of make it look goofy. But let's say in 2012, for some reason, the average gas price was $1.50.
I hope gas never goes up to $3 a gallon.
It will. And then in 2013, let's say it jumps back up to $2. Okay. And then lastly, in 2014, it skyrockets to $3.50. Okay. So we'll put a 4 up here and we go up to $3.50. So if we want to connect the dots, which isn't a big deal, it looks something like this, right? Looks like a constellation. Okay. Looks like a constellation if we wanted to check the dot, to connect the dots. So this is another way to get average rate of change, is just to choose 2 dots. Now this is how we can create super fake news however we want it to be looked at. So if I am a candidate running for office in 2014, and I'm like, man, this other candidate's horrible. All he's done this entire time is make gas prices go up, okay? If I'm that candidate, I'm gonna choose 2 coordinates that make this look like gas prices are skyrocketing, okay? I'm gonna choose, let's choose 2012 to 2014, right? The slope right here is a really nice positive change. So I'm gonna use that in my campaign, right? So the slope, and I'll just keep the same color. So the slope, the average rate of change right here from 2012 to 2014. Now there's no equation. This is a just real world example. If I start here now, this is gonna be tough. So I'm starting at 1.5 and I end up at what, 3.5? So 1, 2, I'm going up 2 and I'm going over 2, right? You guys see that? Up 2 over 2. So the average rate of change is 2 over 2, so it's 1. So what that means, if I'm this candidate, I can say, you know what, from 2012 to 2014, the gas prices rose on average $1 each year, right? Remember, the numerator's money, it's gas price. And then this is really years. So 1 over 1, that's the slope. I can say, you know, this candidate's making gas rise, even though he really didn't have anything to do with it. This candidate's making gas rise from 2012 to 2014, $1 each year on average. And everyone, oh yeah, you're right. Oh God, he's the worst candidate. Okay, rah rah ree. Okay. So then, if you're the other candidate, you're like, man, gas isn't that bad. Gas always goes up. You're not even looking at the right years. I'm going to choose 2 years if I'm that candidate that make me look better, right? I'm going to choose like this first year and this really 1, 2, 3 years in. But if I looked at this line, notice how we've got it trending in a negative way. So if I want to go now in year 10, we were at $3. And at year 13, we were at $2. So this goes down $1 and it runs $1, $2, $3. Okay. So the slope here for the blue line would be -1, 3. So that candidate, or really, I guess that's the person that's already in charge. But that person in whatever gubernatorial, or not gubernatorial, but government position can say, you know what? No. He's lying, which he's not. But you need to recognize from 2010 to 2013, I made gas drop by $1. So on average, that means it dropped 33. Oh, excuse me. It dropped 33 cents a year on average from 2010 to 2013. And I'm not wrong, right? I'm not wrong at all. So the same graph, 2 different candidates can come out with 2 different assumptions. And this is a huge issue we have with graphs, especially currently in this pandemic. Any kind of graph you're looking at can kind of be looked at a few different ways. But yeah, holy cow. I mean, oh my God, we could totally look at pandemic graphs. Hold on, let me see if I can find a good one. COVID 2019 death graphs. Yeah, oh man. Sweet, okay. Not sweet. I mean, this is the death rate, and I'm not going to get into if you believe it or don't believe in it. I don't want to deal with hearing opinions. That's not what this is about. But what I want to show you is that we can make it look however we want, okay? We can make this graph look however we want. So let me share my screen. Okay. Can you guys see the screen? This is the COVID 2019 death graph. That is just the first one that popped up on Google, okay? And it's going through death rates. Now, I assume this is the daily death rate, right? So our peak right here is September 1st. No, September 2nd. There were 27 people that passed away. This is Arkansas, by the way. So there were 27 people that passed away on September 2nd. Like the last one was September 15th, yesterday, 18 people passed away, okay? Now look, trend-wise, I mean, if you just want to step back and look at this, it does look like this thing is trending up, right? I mean, we can agree with that. This, however they want to say the rates are, whatever, I don't care. But you can see that this is like trending up as we go. But you could look at different parts of this graph and make it look as though it's increasing or decreasing a lot worse than it actually is. So let's go both ways. We're going to go crazy COVID way, and we're going to go crazy COVID denier way, because this will be fun. Okay. And this lecture needs something in it. Okay, so if I was someone that thought that this was a hoax, and I felt this was all BS, I'm going to choose coordinates that make it look like this thing is trending down. Okay, so what I'm probably going to look at, I'm going to look at this. See this peak right there on July 20th? Or sorry, I'm sorry, July 28th. Now, we need to think of a day here. Let's say the number one is going to associate with July 1st. Okay? So if number one is July 1st, then that, for my X value, so X equals 1 means July 1st. So my X value would be 28, and then the Y value is going to be COVID daily death, okay? The average, the death that day was what, 20? 20 Arkansans passed away that day related to COVID. Okay, so if I'm going to make it look like it's trending down, I'm going to choose a day over here that's lower than 20, right? Just because I don't want to make it seem too bad, I'm going to choose this date right there, July or August 28th. Okay, so I got to think. August 28th would be, well, there's 31 days in July plus 28. So hold on, let me use a calculator here. That's just, I don't have enough fingers. I don't have enough fingers and toes. So boom, 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 boom. We got 31 days in July plus 28 in August. So 59. That day would correspond to 59. And the total deaths that day were 17. So I'm going to go back to my screen. Stop sharing. So if I wrote these as coordinates, this is what it would look like, right? On July 28th, there were 20 deaths. On August 28th, which correlates to 59, if X equals 1 is July 1st, there's 17 deaths, right? So if I wanted to create or find the average rate of change, I'm really just finding the slope between these 2 points, right? 17 minus 20 over 59 minus 28. So 17 minus 20, that's -3, right? 59, which is what I kind of need, because remember, I think this is all a hoax. This is all going away. So therefore, my slope needs to be negative. 59 minus 28 is going to be 31. So my average rate of change is -3 over 31. Now, what this means is that I believe, on average, there are 3 less deaths per day over 31 days. Okay, so for every 31 days, I'm going to say that the death rate lowers by 3, because that's actually what happened, right? After 31 days, we had 3 less deaths. Now I'm going to put this in my calculator to get a fraction, or I'm sorry, decimal. So clear this out. I get 3 divided by 31. Now remember, it's negative. So -0.097 if I want to round, okay? Now what that means is I'm saying there, now this seems kind of goofy with what we're talking about, but I should say in relation to the real world aspect. But on average, I'm seeing the death rate lower by 0.0, really 0.10 per day. Okay, that's what this is saying. Remember, think of it as over 1. So I say that the average death rate is lowering by 0.097 per day. That's what the simplified slope means, or average rate of change, I should say, means, because this isn't a straight line, right? This isn't a straight line. We're doing all kinds of goofy stuff with it. Okay. So now I'm going to do the same thing, but I'm going to put on my my other hat, right? So that's the person that thinks, oh, everything's fine, it's all going away. Now let's put on the other hat of, no, it's going to be around forever and it's shooting off exponentially. Oh, wait, I need to share the right screen here. Okay, so if I'm going to do that, I'm going to choose some day here in early July. Let's say right there, July 5th. There was only 1 person that passed away on July 5th. Now, if I was going to write that as a coordinate, remember July 5th would be 5 for my X value. my Y value would be 1, right? Now I want to show that this thing is trending up like crazy, right? So I'm going to do July 5th. I'm going to do down here. I'm not going to choose this one. That's just easy. I'm going to choose right there. Okay, you see August 26th. So 31 plus 26. That would be day 57 for us. And there were 21 deaths that day. Okay, day 57, there were 21 deaths. So I'm going to stop sharing the screen. Okay, that's fine, Gracie. Just it's being recorded. I mean, I'm on. Yeah, just watch it later. Okay, so let's find the slope here as we do this. So I'm going to find the slope again, which is just the average rate of change. 21 minus 1 over 57 minus 5. Well, 21 minus 1 is just 20. 57 minus 5 is 52. Right? Now, what this is saying is we're seeing an increase of 20 deaths per day over 52 days. Okay? So on if I wanted to write this out, on average, there are 20 more deaths, not 3 less deaths, but 20 more deaths over 52 days. If I simplify this, 20 divided by 52, I'd have 0.385. So what this means, I'll interpret this part actually. So on average, we are seeing an increase of 0.385 deaths per day per each day. Okay, so when you simplify, now this one would be we're dropping in deaths per day, right? We're seeing 0.097 less per day. But look, both of these came off the same graph, right? Both of them came off the same graph. Now, the issue is you would need to say where the X values were. And I didn't say that on both of those. And the person that comes up with this graph should have to say that. If they said, oh, we're seeing a drop of 0.097 per day. Well, yeah, from, if you just looked at the 28th and the 59th day, that's true. And the same thing here, we're seeing it rise 0.385 per day. Yeah, if you just looked at 5 and 57, that would also be true, okay? Now, in reality, if we wanted to find a nice trend line, let's go back here. Share this again. Look, this thing, I'm going to say, in my highly educated opinion on statistics, that this thing is trending up. But it's not as drastic as that second one, right? The second one is, if we connected those dots, it's like a huge trend line. It's more like we chose like maybe here, this June 10th. So that would be, so let me get a new sheet of paper. June 10th, so that would be 10, right? There were 4 people that passed away that day. And then I would connect it maybe with this guy right there on September 7th. September 7th. Okay, so it's 31 plus 7. So the 69th day, there were 14 deaths, okay? And what's going to happen is we're probably going to see an average rate of change in between those two, right? We should. So let's kick it over back to my corner. So I've got on the 10th day where there were 4 deaths, on 69th day where there were 14 deaths. So we get M equals 14 minus 4 over 69 minus 10, right? 14 minus 4 is 10. 69 minus 10 is 59. So what we're saying, if we kind of picked an average, a true, probably real average death rate right here, we're seeing 10 extra deaths every 59 days. So every 2 months, if we stayed on this trend, guys. So let me go back to what I'm showing you. And I know this is probably the most morbid topic I've talked about. But if we stayed on this trend, we would see an extra, 10 deaths per day over 2 months. Okay, so about five extra deaths per day per month. Okay, so let's stop sharing here. And if I simplify that, I would get 10 divided by 10 divided by 59. So 0.169, okay? So I'm looking at, for each day, we're averaging about 0.169 extra death per day. Okay, that's the way to think of it. So each day in Arkansas, we're averaging about 0.169 extra deaths per day. That's a pretty, I mean, it's a horrible example in what we're talking about, but it's a good real life example that we're all living through right now. Okay.
Mr. Fairley, I have a quick question.
Yep. Is it about death rates in COVID?
Not necessarily. I missed the tests
I'll
last
talk to you after
weekend.
class. Nathan,
I had to work.
Yeah, I'll talk to you after class, Nathan.
Okay, cool.
Okay. Are there any questions about this? So for homework, are we back on my screen? Yeah, I'm not sharing screen. Okay. So for homework, I want you to look at number. This starts on page 266. And I want you to look at the first part's just that parallel perpendicular line stuff. So 1 through, let's do 1 through 29 odd. Okay. 1 through 29 odd. It's not a long section. It's kind of just an addition. It should be called 2.3b in all honesty. It's not a long section, but it's a section that we're covering. Okay. Does anybody have any questions about this or about the last section? Anything moving? Now, I have a quick question. You guys that have taken this test already, can you look and see what you missed? Because I tried to add that. Chastity's saying no, but I swear I added
Yeah,
that.
I missed 2 points and I want to know.
Oh, you want to know? You can't, and you tried to go back in there and it wouldn't let you?
I mean, I can't even go back and see. There's not a tab in there for our grades. And so, but when you click on test, it just says nothing now. So yeah, I can't go back and see what I missed.
Oh, it's not available anymore. Okay, hold on. Sit tight. This is me just trying to hold on.